Our topic for today is about the approaches in project-based, problem-based, and inquiry-based instructional plans and multimedia learning tools. With the discussants Jon-Athan Maipa, Jillian Christian Merit, Bella Hagulino, and Mike Daniel Rabusa.
In today's dynamic educational landscape, innovative instructional approaches are essential for engaging students and fostering deep understanding. Project-based learning or PBL, problem-based learning or PBL as well, and inquiry-based learning or IBL have emerged as powerful student-centered methodologies that encourage active learning, critical thinking, and problem-solving skills. These approaches, while sharing common ground, also have distinct characteristics that cater to diverse learning styles and objectives. We will delve into the intricacies of these three base learnings, examining their core principles, implementation, strategies, and potential benefits. We will also shed light on the diverse range of multimedia learning tools available and how they can be effectively integrated into these instructional approaches to create dynamic and impactful learning environments. By understanding the synergy between these innovative methodologies and cutting-edge technologies, educators can empower students to become active learners, critical thinkers, and creative problem solvers, ready to thrive in the 21st century.
Project-based instructional plans. Project-based learning or PBL is an instructional approach where students engage in a real-world challenge or question, leading to a tangible product, presentation, or solution. It emphasizes hands-on learning, collaboration, critical thinking, and creativity. Approach in project-based learning. Project-based learning follows a structured approach to engage students in real-world problem solving. These are driving questions, align projects with curriculum objectives, a central question or problem that guides the project. Example given, how can we create a sustainable garden for our school? Inquiry and research. Students explore and gather information. It encourages students to research, investigate, and gather information related to the topic. Hands-on application. Creating a product or solution. Students actively create, design, experiment, or develop solutions. Collaboration. Teamwork and peer interaction. Working in groups or teams to develop ideas and solve problems. Iteration and feedback. Revising based on feedback. Opportunities to refine work based on peer or teacher feedback. Final product. A presentation, model, or project outcome. Showcasing the project outcome. Example given, reports, presentations, prototypes, or models. Reflection. Evaluating learning and improvements. Students reflect on their learning process, challenges faced, and improvements for future projects. Now, let's proceed to application. PBL can be applied across different subjects and grade levels by integrating real-world challenges that encourage inquiry, collaboration, and hands-on learning. Below are some examples of how PBL can be applied in different subjects. Project-based learning can be applied across subjects by engaging students in a real-world challenges that promote inquiry, collaboration, and hands-on learning. In science, building a sustainable ecosystem. Research, experiment, and track changes. Math, designing a budget for an event. Financial planning and calculation. English, writing and publishing a class magazine. Writing, editing, and design. While in technology, building a solar-powered car. Engineering and testing prototypes. These have key benefits. It enhances critical thinking and problem solving, it promotes collaboration and creativity, and it also connects learning to real-world scenarios.
Now, let us move on to problem-based approach. But before that, let us define first what is problem-based instructional plans or PBIP. So PBIP, these are learning experiences centered around real-world problems that students must solve. They encourage active engagement, critical thinking, and collaboration. Students learn by applying knowledge and skills to find solutions. How about the problem-based multimedia learning tools or PBMMLT? These are the digital resources that enhance the learning experience by incorporating various media formats like videos, animations, audio, and interactive elements. They support problem-based learning by providing access to information, facilitating collaboration, and creating engaging learning experiences. Now, what is the difference between PBIM and PBMLT? The key difference lies in their nature. PBIM refers to the structure of a learning experience itself, focusing on the problem-solving process. It dictates how students engage with a problem, research, collaborate, and present their findings. On the other hand, PBMMLT are the tools used within the PBIM framework. They provide the resources and platforms for students to access information, create multimedia presentations, collaborate, and engage with the learning experience in a more interactive and engaging way. Think of it like this. PBIM is the recipe for a dish, while PBMMLT are the ingredients and cooking tools. You need both to create a successful and delicious meal. Now, let us move on to the examples of problem-based instructional materials in culture and arts education. First example of problem-based instructional plans is preserving cultural heritage. Students research the impact of globalization on a local art form like traditional weaving. They then develop a plan to preserve the craft, including workshops, community outreach, and digital documentation. Next example is creating a community mural. Students design a mural that reflects the history and values of their community. They research local stories, interview residents, and collaborate on the artwork using different artistic techniques. The third example is curating a virtual museum exhibit. Students curate a virtual exhibit showcasing the work of local artists. They research the artists and their works, create digital descriptions, and use multimedia tools to present the exhibit online. Now, let us proceed to the examples of multimedia learning tools. First is video editing software. Students create documentaries about local artists or cultural events using video editing software to capture, edit, and present their stories. Next is graphic design software. Students design posters, brochures, or websites promoting cultural events or exhibitions using graphic design tools to create visually appealing materials. Lastly is the virtual reality and augmented reality tools. Students use VR or AR tools to explore cultural sites, interact with historical figures, or experience different art forms in an immersive way. Now, let us proceed to the main topic, which is the different approaches to problem-based instructional materials and multimedia learning tools. First, we have digital storytelling approach. Students create interactive and engaging digital narratives using various media such as images, audio, video, and text to explore cultural themes or artistic concepts. They might create a multimedia presentation about a specific cultural tradition, a digital comic exploring a historical event, or an interactive story about a fictional character inspired by a particular art style. This approach fosters creativity, digital literacy, and narrative skills. It is problem-based because students are challenged to research, analyze, and communicate their understanding of a cultural topic or artistic concept through a creative, problem-solving process. Next, we have virtual museum gallery approach. Students curate and present virtual exhibitions showcasing cultural artifacts or artworks using digital platforms like Google Sites, Wix, or dedicated museum software. They research, select, and arrange digital representations of artifacts, write descriptive text, and incorporate interactive elements like audio tours or 360 views. This approach develops research, curatorial, and presentation skills. It is problem-based because students face the challenge of organizing, presenting, and interpreting cultural artifacts or artworks in a virtual space, fostering their critical thinking and curational skills. Next, we have interactive simulation approach. Students engage with interactive simulations that recreate cultural experiences or artistic processes. For example, they might use a simulation to explore the process of creating a traditional pottery piece, experience a virtual visit to a historical site, or participate in a simulated cultural exchange. This approach enhances engagement and understanding by providing hands-on experiences without physical limitations. Next, we have interactive simulation approach. Students engage with interactive simulations that recreate cultural experiences or artistic processes. For example, they might use a simulation to explore the process of creating a traditional pottery piece, experience a virtual visit to a historical site, or participate in a simulated cultural exchange. This approach enhances engagement and understanding by providing hands-on experiences without physical limitations. Next, we have augmented reality or AR and or virtual reality or VR approach. Students use AR or VR technologies to immerse themselves in cultural environments or artistic experiences. They might use AR to overlay digital information onto physical artworks in a museum or use VR to explore a virtual reconstruction of a historical city. This approach offers innovative and immersive learning opportunities, providing unique perspectives and enhancing engagement. Lastly, we have data analysis approach. Students analyze digital data related to cultural trends or artistic practices. They might analyze social media data to understand how cultural events are discussed online. Use data visualization tools to represent the geographic distribution of a specific art form, or analyze audience data to understand the reception of a particular artwork. This approach promotes data literacy, research skills, and critical thinking. To conclude everything, technology-enhanced problem-based learning in culture and arts education offers engaging, authentic challenges that foster critical thinking, creativity, and essential 21st century skills. These diverse approaches, from digital storytelling to data analysis, transform passive learning into active problem-solving, resulting in deeper understanding and skill development.
Inquiry-based instructional plans. Inquiry-based learning is a student-centered teaching method where students actively ask questions and explore real-world problems. This approach encourages independent learning, critical thinking, and creativity, often through hands-on activities that connect classroom lessons to real-life experiences. Students gather information, analyze it, and build their understanding. Multimedia tools like videos, audio, images, and text help make learning more engaging and meet diverse learning needs. The next one is the key elements of inquiry-based learning. Number 1 is essential and open-ended questions, where students spark their curiosity and promote critical thinking. Next is differentiated learning. It tailors activities to accommodate different learning styles. Next is collaboration. It encourages group work and discussions. Next, research and data analysis. It guides students in gathering information and drawing conclusions. And the last one, for the key elements of inquiry-based learning, is the reflection and synthesis. It is where students reflect on their learning process and understanding. Here are the examples of inquiry-based learning. First one is science experiments, where students ask questions and analyze results. Next is field trips. Students explore real-world problems. Next one is classroom debates, where students critically evaluate both sides of a topic. Next one is projects. Students work on related tasks, deepening their understanding. Now, let's proceed to the multimedia learning tools for inquiry-based learning. The first one is the interactive simulations. It allows students to manipulate variables and explore concepts virtually. Next is the video platforms with annotation features. It enables students to pause, rewind, and add comments on key points in videos. Next one is online collaborative tools. It facilitates group brainstorming, document sharing, and real-time feedback. Next is the Learning Management Systems or the LMS. It manages assignments, discussions, and student progress tracking, while data visualization tools present complex data in interactive graphs and charts for analysis. And the last one for the multimedia learning tools for inquiry-based learning is the virtual field trips. It explores locations and scenarios remotely through 360-degree videos. Now, we will tackle strategies for implementing inquiry-based learning. Number 1. Start with a question. Begin with a question to spark curiosity. 2. Allow exploration. Let students explore the topic on their own. Number 3. Encourage discussion. Foster deeper understanding through conversations. Next is provide resources. Offer tools and materials to support exploration. And the last one is summarize learnings. Summarize key points to reinforce understanding. In conclusion, inquiry-based learning enhances student engagement, critical thinking, and real-world connections by encouraging exploration and problem-solving. Students act as researchers, asking questions and sharing findings. By focusing lessons on central questions, teachers foster active learning and deeper understanding. This method connects classroom knowledge to real-world applications, making learning both engaging and impactful.
Imagine school where you don't just listen to the teacher talk all day. Instead, you're doing things. That's what project-based learning, PBL, problem-based learning, also PBL, and inquiry-based learning, IBL, are all about. They're like learning adventures. With PBL, you might build a robot, create a play, or design a website. You work on a big project over time, learning all sorts of things along the way. Problem-based learning is similar, but instead of a project, you tackle a real-world problem, like figuring out how to reduce pollution in your neighborhood. In inquiry-based learning, you get to ask the questions. You explore a topic you're curious about, like why volcanoes erupt, and investigate it yourself. All these ways of learning are different from traditional school where you mostly listen and memorize. Here, you're actively learning, figuring things out, and working with others. It's like being a detective, an engineer, or an artist all at the same time. And to make it even more fun, we can use school tools like videos, simulations, and online resources. These tools can help us learn in exciting new ways. So, instead of just reading about science, you might build a volcano model. Instead of just hearing about history, you might create a documentary. PBL, and also IBL make learning more engaging, help you understand things better, and teach you important skills like problem solving and teamwork. It's learning by doing, and it's way more fun.